Hello students, welcome to the next lecture on the CSIR net mathematics. Today I will explain you how you can solve the system of the differential equation in a simple manner. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of the CSIR UGC net, and you can see the various PY question series is available in this playlist with the help of the shortcut tricks. So let's start with this one, how you can solve this PY question series. So before that, I will give you a simple shortcut tricks for that. What is the meaning of the system of the differential equation? Like of here. Your first step, whenever you have to see the system of the differential equation, your first step is to write this matrix A. How you can write that? You can, for example, corresponding to this, what is the coefficient of x minus 1, coefficient of the y plus 1, coefficient of x 0, coefficient of y minus 1. Similarly for here, how you can write that is a minus 1, is a plus of t, is a plus of t and minus 1. So your first step is always to write this matrix A. Then find the eigenvalues and the eigenvectors corresponding to this matrix A. And this is the first method. I will tell you the second method also with the help of the various examples. Now once you can find the eigenvalues and the eigenvectors, then check whether the eigenvalues are distinct or some of the eigenvalues are equal. If eigenvalues are distinct, then you can write the solution. This is my solution, is C1 into vector, eigenvector of this one, where C1 and C2 are my arbitrary constants. However, if the two eigenvalues are same, then you can replace this constant as C1 plus C2 times of t as you did in your ordinary differential equation. For example, if you have the two values C1 and 1, then you always write the constant in this manner. The same I have written this case. If you have to find the eigenvectors corresponding to the lambda, if there is only one eigenvalue, eigenvector you can find, when this case will be happen when the algebraic multiplicity is not same as geometric multiplicity. Then you have to find only the one eigenvectors. The second eigenvector you can find it by using the concept of generalized eigenvectors. That means a minus lambda I of the eigenvector, instead of the 0 you have to write the previous eigenvector. Another concept is, once you have to find the Wronskian, again corresponding to the matrix A, you can find the trace and write the Wronskian of the solution here. Or you can also write it as this will be equal to trace of the matrix. Find this into here. Fine. This is the formula for here. Now let's start with the PY question series. So first of all, it's my two variables. So the size of the matrix A will be my 2 cross 2. What is given to you is a 2 cross 2. The trace is my 0. So you can take this is my 0, or you can choose this is also the trace 0. Fine. But the simplest one is my 0 and 0. Determinant is my positive. So I can choose that determinant is 1, which is greater than 0. So what is that? Is a minus 1, is a plus 1. Fine. This is the easiest way you can choose. Now, can you find the eigenvalues of this? Lambda square minus 0 plus 1 is 0. So lambda will be plus minus iota. Fine. Now they have the distinct eigenvalues. Fine. Now since it is a complex number, so the solution will be in the form of the cos of t and sine of t. Now clearly say y of 0 will be 0, that is my y1. So which one will be the 0? Sine of t. And second number will be my cos of t. Now are they constant? No. Are they oscillating? Yes. Are they monotonically decreasing for all the t which is greater than 0? No. Because sine of t is my increasing in the case of 0 to pi. While from the pi to 2 pi you can see it's a decreasing, and so that's a monotonic, not increasing and not decreasing. So the right answer is C is the correct answer. Okay, consider again the system of the differential equation. Can you write the equation? Coefficient of x1, x2, x3, x1, x2, x3, x1, x2, x3. Fine. Solution is given to you as alpha t e raised to power 2 into t. Then your target is to find the value of alpha. I think it's very simple. Look at that. What is the meaning of this? What does it implies that? That means 2 is the eigenvalue of A. Fine. What does the meaning of this small t? That means it is a repeated root. Fine. Clear? The degree is my 1. That means it's repeated one time. So that means it's a 3 cross 3. It means the two eigenvalues are my 2 and 2. Can you find the third eigenvalue? Third eigenvalue can be any of things. So I can say this is my A. Or A is already written that. I can say this is my B. Then your target is to find this lambda. So that's a very simple. I can find the trace. This is my trace. Fine. Product of the eigenvalue is nothing but my determinant of the matrix. So what is the determinant of this? 1 times 2 lambda minus of 2 minus of 2 0 plus 1. Sorry, it's a 2. It's a twice. Plus twice of 0 plus of 2. So what is that? 2 lambda minus of 2 minus of 2 minus minus plus 4. So here. Fine. So that means lambda will be twice of B. So I can substitute this value here. What is that? It's a 1 plus B is my 2B. So B will be my 1. So once B will be 1, lambda will be my 2 is the right answer of the problem. Okay, look at this one. Again, it's a system of the equations. It's a 3 cross 3. Can you find the eigenvalues? Now since it's a lower triangular matrix, so eigenvalues are my minus 2, minus 2, minus 2. Fine. Now your target is to find the x of t. Xt is my defined as here. So very simple. You can see how you can write the solution is corresponding eigenvector is my v1 e raised to power minus. Fine. Then second, because it's a repetition, so I can write this number as here. Fine. It is repeated 3 times, t square plus v2t plus v3 of here. Clear? Now out of these 3, which one is the x1, x2 and x3? Look at the last line. Last line is corresponding to my third solution, dx3 upon d. So I can written this is x1, x2, x3. That means minus 2x3. What does it implies? x3 will be e raised to power minus of. So that means here. Fine. Now look at the second equation. This is corresponding to x2 and x3. That means only the two values are there. So this is my x2. This is my x1. Fine. Now once you know these values, I can find the values of the capital Xt. What is the mode of Xt is? That means I can put as a square and then square root. If I square them, e raised to power minus 4t, and again I can take the square root, it will be my this number. So it is my v1 square plus second number square, third number square. Then take t as infinity. What is this number? This number will be 0. So 0 into something is my 0 is the right answer of the problem. Okay, look at this another one. A is my n cross n matrix. I can choose the value of the n as my 1. So that means A will be my 1 cross 1 value. Fine. And whose eigenvalue is my lambda 1. The corresponding eigenvector will be my v1. Since the vectors are my linearly independent, so I can choose as much smaller as I can choose. So I can choose v1 is 1, you can choose v1 is 2, you can choose any of the number. So therefore your system of this equation will be A is nothing but my lambda 1 x plus e raised to power lambda 1 into t. v1 I can consider as a 1. So what does it mean? Now you can see that. Now what is the size of this matrix is 1. That means it is a single ordinary differential equation. So once you know the single ordinary differential equation, Can you find the homogeneous solution? E raised to power lambda 1 into t constant. Can you find the particular solution? 1 over d minus here e raised to power of this. So what does this mean? It's a 0, so I can multiply by t e raised to power this over 1. So what is my complete solution is c e raised to power lambda 1 t plus t times of here. Now look at the options. Does not have a solution of this form, but it is a solution of this form definitely for any vector, so that option is cancelled. Has a solution of this form for some vector a, yes, because c is my arbitrary constant here. Has a solution of this form, this, fine, plus t times of this into b. So for some b, yes, I can choose b as a 1. Here v1 I can take as a 1. If I choose this number is my b, then what will happen? This is my b, this is my b, so into b. That means this is also the solution. Does not have a solution of this form, but it is already have a solution. So it is, and it is given that for any vector, but we can see whenever b is equal to 1, we will get a solution. So the right answer are b and c are my right answers. Okay, look at this another one. Again you have the system. Find the eigenvalues. Eigenvalues are my 1 and minus 1. Find the eigenvector corresponding to lambda is equal to 1. So the system will be 0, 2, 0, minus of 2. Eigenvectors are say x and y. It will be 0. So that means y is equal to 0. The first eigenvector will be here. Corresponding to the second, that is corresponding to the minus 1. It will be 1 minus 1, 2, 0, minus 1, 0 into eigenvector. So that means x plus y will be 0. So the second eigenvector will be my 1 minus 1. So therefore your solution will be c1 into v1 corresponding to the first eigenvalue. This is with respect to x, fine, because they are independent variable is my x, plus c2 1 minus 1 e raised to power minus x. So if I open this bracket, first one is c1 e raised to power x, c2 e raised to power minus x, and second pair is minus c2 e raised to power minus x. So what is the meaning of that? Your y1, that's the first component, will be c1 e raised to power x, c2 e raised to power minus x. Your second solution will be minus c2 e raised to power minus x. Now look at the initial condition. This is the first method, as I told you. The second method, one more I will explain you. So what is that? y2 of 0 is given as a minus 1. So what does it mean? c2 will be 1. y1 of 0 is given as a 2. That means c1 plus c2 as a 2. c1 will be 1. So your final solution will be y1 is e raised to power x, e raised to power minus x. y2 will be e raised to power minus e raised to power minus x. Now look at the options. As x approaches infinity, this number will goes to the 0, this number will goes to the 0, this will goes to the infinity. y1 infinity, y2 0, correct. As x approaches infinity, y1 goes to the 0, wrong. As x approaches minus infinity, so you can see if x1 approaches minus infinity, if x approaches minus infinity, the first one, this is 0, this is my infinity, so whole term will be infinity, fine. This number y2, when x approaches minus infinity, this will approaches to infinity, but because of this negative, it will goes to the minus infinity. So yes, this option is correct. When x approaches minus infinity, both approaches minus infinity, that's the wrong answer. So correct options are A and C are the right answer of this problem. This is the first method. There is one more method. How you can solve that problem is, so let me here. So for that you have to write the system of the equations. dy, first variable is 1, 1 and 2, y1 plus 2y2. Second equation, dy2 is my minus y2. Now from here Can you find the value of the y2? Y2 is constant e raised to power minus x. Now I can use this initial condition. Y2 0 is my minus 1. So c will be minus 1. So y2 will be my minus e raised to power x. I can substitute here. What is my this? Y1 dash minus y1 is minus twice e raised to power minus x. So can you find the solution of this? So y homogeneous is c e raised to power 1x, and particular solution is 1 over d minus 1 2 e raised to power minus x. Or you can also find the integrating factor as e raised to power minus 1x. You can solve like this way also. So anyhow, it is e raised to power minus x. So your y1 will be c e raised to power 1x. Fine. Complementary solution plus particular solution. Now given that y of 0 is my 2, so that means c1 plus 1 is equal to 2. c1 will be 1. So your solution will be ex plus e raised to power minus x. y2 will be here. Again you will get the right answer as a and c. Okay, look at this one. Again there are the two methods. Fine. The first method, I can write the equations. This is my x prime is x plus y prime is minus y. So from this case I can obtain y is my e raised to power minus x, some constant. Fine. I can substitute in the first equation. X prime minus x is c e raised to power minus x. So this solution will be x homogeneous part will be c is already there, so c1 e raised to power x, and particular solution will be d minus 1 c e raised to power minus x. It is minus c over 2 e raised to power minus x. So your solution will be some constant c1 e raised to power minus x minus c over 2 e raised to power minus x, and y will be c e raised to power. So how you can write in terms of the basis? C1, coefficient of the C1 is e raised to power x, 0. Coefficient of the C will be minus half e raised to power minus x, and coefficient of this will be here. Fine. So that means the first component will be e raised to power x. That component is 0. E raised to power x and 0. E raised to power x and 0. E raised to power minus x, this will be here. Fine. You can see I can write this again e raised to power t. There is no e raised to power t, and minus half e raised to power minus t, e raised to power minus t. That's a similar of this. So definitely this is the correct option. E raised to power minus t, which is similar. I can write this component also as e raised to power minus of x and minus of 2 e raised to power minus x. Fine. Sine hyperbolic. Sine hyperbolic I can written as e raised to power t, e raised to power minus t divided by 2, which is similar of this. Fine, because e raised to power t will be half comma 0. Half comma 0 is nothing but here, so which is also the correct option. E raised to power cos e raised to power t plus e raised to power minus of t divided by 2. Does it equal to the same thing? First part is okay, but you can see it's a half and plus 1, but we need a opposite sign. One is a negative, one is a positive, but from here we got both as a positive sign. So this option is cancel out. So C and D are my correct answer. Fine. This is the first method. Second method is you can write, what is the second method is, you can write the equation 1, 1, 0, minus 1. What is the eigenvalues? 1, minus 1. Can you find the eigenvectors corresponding to the 1? 0, 1, minus of 2. So that means from here the second component will be 0. So 1, 0, and corresponding to the minus 1, 2, 1, 0, 0. Fine. So from here you can see 2x plus y will be 0. So your second component will be, if you take this is my 1, it will be my minus 2. Fine. So your solution will be x will be c1 into first eigenvector corresponding eigenvalue plus c2 1 minus of 2 e raised to power minus t. So you can see c e raised to power t plus c2 e raised to power minus t, and this case will be minus c2 e raised to power minus t. Fine. Now you can see the first component will be the 0 and e raised to power minus t, but there is no first option cancel. E raised to power minus of this number will be e raised to power t and 0. Can you obtain them? So this is my c1. So this option I can obtain by taking c1 is my 1, c2 will be 0. This component, how I can obtain them from here? I can take c2 will be e raised to power minus, so I can c2 will be minus half, it will be the minus half, c1 will be plus 1. Fine, this option is correct. This option e raised to power minus of t, so c2 will be, I can take as a plus 1, c1 will be my 0, so this option is corrected. This I can return like here. Fine, I can take c1 is half, c2 is my minus half, this component becomes my sine hyperbolic, and this is my plus 1, this will be here. But because of this, it's a positive sign and it is a negative sign. You are unable to make this quantity from here. So the right answer is again C and D. Okay, again you can see from here, can you find the eigenvalues? Eigenvalues are my minus 1 and minus 1. Fine. Or the best way is I can write the system of the equation y1. So y1 prime is minus y1 minus y2, y2 prime is minus y2. From here I can say this is e raised to power with respect to t minus of t. Fine. I can substitute here y1 prime plus y1 is c e raised to power. So can you find the value of the c? Y of y2, y of 2 is my 1, so c will be my 1. Fine, this will be here. Now can you find the solution of this auxiliary equation? It will be e raised to power minus of t. What is the particular solution is? D minus 1 e raised to power minus t is a 0, so it will be here. So what is my y1 is a constant, c e raised to power minus of t plus t e raised to power here. Now y of 0 will be 0. So y of 0 will be 0, it means this c will be my 0. So finally y1 will be, so I can write here is, what is my final solution? C will be 0. So that means y1 will be t e raised to power minus of t, y2 will be e raised to power here. Now look at the options. Y1 monotonic increasing. So clearly say, if you take the derivative, it is my decreasing whenever t is my greater than 0. So it's a increasing, cancel out. Y2 is increasing, greater than, cancel out. Y2 is my decreasing, fine. Is the y1 is also decreasing? What is the y1 derivative? It's a e raised to power minus of t minus of this. So it will be 1 minus of this. So whenever t is my greater than 0, it's a monotonically decreasing? No, because if I choose t is my 0.5, it is my greater than 0. Whenever t is my greater than 1, this number is my negative, so it's a less than 0. y2 is also less than 0. Right answer is capital D is the right answer. Okay, look at this another one. Consider the solutions of the homogeneous system is a 3 cross 3. Which of the following is my true? y1 and y2 form a basis. It can never form a basis. What is the size of this? It's a 3 cross 3. So we need a 3 cross 3 matrix. Okay, so we need a y1, y2 and y3. So that's a wrong. y1 and y2 are li. So when it will be li, can you return this form of here? but you can see it's a minus e and it's a 0. So e raised to power minus 3 can never be multiply of this. So therefore y1, y2 are Li. Fine. But do not form a basis. Yes, it's a correct option. There exists another vector y3 so that this becomes a basis. Okay. Look at that from the y1 and y2. If you compare them, what are the eigenvalues? Minus 3, minus 5. Fine. Can you find the third eigenvalue? What is the trace? The trace will be minus 3, minus 5. Third eigenvalue, say A, it will be minus 15. So A is my minus 7. And you can see all these three numbers are my distinct. Fine. So if they are distinct, then it form a basis. So that means this option is again cancel out. So it do not form, y1, y2 do not form a basis. Correct option. Yes, it's a correct option. RLD, it is not a LD, it's a LI. So the right answer are B and C are the correct answer. Okay, look at this another one. Y0 is greater than 0. Is there any number? So I can choose any number here. Z0 is any number. I can choose again 1. Alpha can be any number which is greater than 2. I can choose here. Consider the following differential equation. We can say the solution exists globally if it exists for all t greater than 0. Both star and double star. Okay. So let me firstly solve this part. Is a y square. Fine. So what is the meaning of that? Minus 1 over y is t plus c. Now y0 is y0. Y0 I consider as 1. So can you find the value of the c? So y0 c will be my minus 1. So therefore value of y will be minus 1 over t minus 1. Does it always greater than 0? No. Because if I choose simple t is my 3. Fine. This number is negative. It means star not global. Look at the condition. Exists globally when if it exists for all t greater than 0. Clearly say y does not exist when t is equal to 1, which is greater than 0. So that means this is not global. There exists a global, wrong answer. Fine. Now look at the right hand side. Second part. dz over this will be alpha I have taken as a 2. So this will be minus 1 over z is minus of t plus c. This I have written like of this z square is minus, then I have to integrate them. So minus I can cancel out. It is 1 over z is t plus c. Okay, minus c again I consider as a c. Now z0 again I consider as a 1. So what is the value of the c? C is my 0. Fine. Z0 is my, so what is the answer of this? So z will be 1 over t. Now since t is my strictly greater than 0, so that means z exists for all t which is greater than 0. So that means this has a global solution. So none of them have a global solution. That's cancel. So only left option is my D is the correct answer. But anyhow we will see that there exists a global solution, yes, and there exists a capital T such that limit of small t belongs to the capital T y. Y is my first solution. That means I have to return this number. Fine. It goes to the plus of infinity. So does there exist a capital T? Yes. I can choose the capital T is my 1, which is a finite. So when you choose capital T will goes to the 1, it will goes to the plus infinity. Yes, this is my correct answer of the problem. You can see, you can simply choose the smallest number and get your answer in a very simple manner. Okay, again this is the differential equation a plus b of y. So I think there is no need to solve them. What is the solution of this problem? That is c times a plus b of t. That's over. So okay, this option is not true. Remember that you can't return this number as this into this. Fine. This, because we all know AB is not equal to BA in general. Fine. So that means you can't separate them. This option is okay, correct option. This is a negative sign, this is a wrong option. So C is my correct answer of the problem. Okay, again there are the two methods. Okay, firstly I can solve this. I need to find the x. So I can see x is minus x plus y. So from here, can you find the value of the y? Y is my c times e raised to power minus t. Y of 0 is my 1. So c will be 1. So y will be my x prime plus x is e raised to power minus t. So from here you get this solution as homogeneous solution will be c e raised to power minus 1 into t, and particular integral will be 1 over d plus 1 e raised to power minus t. So which has a root, so I can multiply by t and of this case. So your solution will be x is c e raised to power minus of t plus of this case. Now x of 0 is my 1. X of 0 is my 1. So that is my c 0. So c will be my 1. So I can return this is plus t times of here. Fine. This is my x, and what is my y is e raised to power minus t. So x is equal to yt, wrong. X is equal to minus of yt, wrong. E raised to power minus t, what is that? I can return this is y also, yes. E raised to power minus of t I can take as a common. It is 1 plus t, that is the right. So first and third are my correct answers. There is one more way how you can do that. Look at this equations. I can differentiate them. X double dash minus x dash plus y dash. Because my target is to find the value of the x, I can substitute the value of y dash. Y dash is minus y. But we need all as a in terms of the x. So how you can remove this y? So how I can remove this y? Okay, I can find the value of the y from here. It is minus, what is the value of the y is x dash plus x. Now you can see this is x double dash plus 2x dash minus of x is 0. Now it's a single ordinary differential equation. M square plus 2m is a minus m, this is a plus 1. So my roots are minus 1, minus 1. So what is my solution? C1 plus C2 into constant. Constant is my t of e raised to power minus. Now you can substitute this value here, you will get the constant, and y I can use an y as here. One more method, instead of solving like this way, there is one more method. I can write the matrix A. It will be minus 1 plus 1 0 minus 1. So eigenvalues are my minus 1 and minus 1. Fine. So you have the two repeated eigenvalue. So definitely one will be here into V1. Second one will be plus e raised to power minus 1t. Fine. Now clearly say this is dependent on the one variable. So this will be my y. This will be my x. Now you can find the eigenvalues. What is the eigenvector? Can you find the eigenvectors corresponding to lambda is minus 1? So this will be 0, 1, 0, 0. So what is the second component will be 0. So V1 will be 1, second component will be 0. Second component will be 0. Fine. Then how you can find the, because now you are unable to find the second eigenvector. So for that we will use the generalized eigenvector concept. What is the generalized eigenvector concept is a minus lambda I of V2 must be equal to the obtained value. So what is the a minus lambda I? That is the same number, fine, into xy, which is 1 comma 0. So from here, if you compare them, y is my 1. So what is my V2? 1. This number can be anything, so I can assume as a 0. So therefore, I can substitute this both value as here. So what is my y1? 1 comma 0, fine. What is my x? V1, this is my V1. V2 will be 0 comma 1. So V1 into t plus of this, that will be t comma 0 and plus 0 comma 1 into e raised to power t. So that will be t e raised to power minus of t e raised to power here, fine. So this is my x, this plus this you can substitute here and you will get the same answer as here. Okay, look at this another one. Consider the initial value problem. Which of the following solution is blow up in the finite time? Okay, look at the first case. Always whenever you are talking about the finitely below, finitely up, finitely down, find the critical point. What is the critical point of this? When first derivative to be 0, that means x cube will be 0, x will be here, fine. So if you look about that, x will be here. Then look at this value. This is the value of this case. If I look at this is my here, fine. So what is the value of this dx by dt at a 1? So this is my x cube. So it will be greater than 0 if x is my here and less than 0 if x will be this case. So whenever x is my positive, this value will be my increasing, fine. Whenever, and this value lies in this case, 1 is belongs to the 0 to infinity, and you can see the graph of this is increasing, that means upward. So the first option is the correct one. Look at the second one. Find the critical point. X sine of x square will be 0. Either x is 0 or x square will be n pi, fine. That means x will be 0 or x will be root pi, 2 pi, 3 pi and so on. Under which case the 2 lies in between them, fine. So I have to draw x is equal to pi, fine. This is my 2 pi, this is my time, this is my x. Now whenever 2 lies in between them, here is something as a 2, fine. Now look at that, whenever, because 2 lies in between them, fine, choose any number in between them. So that means x square must lies between pi and 2 pi, fine. So if x square lies between pi and 2 pi, choose any of the x square. So 180 degree, and so I can choose as a 270 degree, for example, fine. Or you can choose it as a 245. That means it lies in the third quadrant, fourth quadrant. When this lies in the third and the fourth, this number will be my negative, fine. That means this value should be decreases because it's a negative. So that means it's a decreases, it means it's a blow down, but he said blow up. So this option is cancelled. So first option is correct, second option is incorrect, is the right answer of this problem. Okay, look at this another one. Again it's a 2 cross 2. Can you find the eigenvalues? So lambda square minus of 2 lambda minus 3 plus 4 plus 1 is 0. So that means 1 and 1. So the coefficient matrix has the repeated eigenvalue 1. Has only one linearly eigenvectors. There are the two methods. You can prove that the geometric multiplicity of this eigenvalue is my 1 because only 1, fine. So what is geometric multiplicity is n minus rank of a minus, so what is that, 2 minus, what is the a minus of this, 2, 2, minus of 2 and minus of 2. Clearly say the rank is my 1. So 2 minus 1 will be 1. So that's the correct option. Or you can find the eigenvalues. 2 a minus lambda I 2 of x comma y is equal to 0 comma 0. So that means x plus y will be 0. So that means eigenvalues are 1 and minus. This is the eigenvector. The general solution of this problem will be here. Now one eigenvalue. So this number is my v1. Fine. Can you find the v2? So again I can start from here. Minus 2 minus 2. Fine. This should be equal to this eigenvector. So clearly say from here it will be x plus y will be 1 over 2. Fine. So what is the second eigenvector? If I consider the first number will be my t, fine, other number will be half minus t. So you can see 1, this is my v1, this is my v2. The vector x1 and x2 are my linearly independent. Clearly say minus half can never be written in this form. So definitely they are my Li. Or moreover, these are obtained from the journal. This is the concept of the generalized eigenvectors. So they are my Li vectors. So all are my correct answer of this problem. Okay, look at this another case. Which of the following y0 is 1, 1, 1? Is it satisfied? Yes, all are satisfied. Look at that. What are the eigenvalues? 0, 0, 0. Fine. Now it means the solution will be 1. It repeated 2 times. Here e raised to power 0 v1 t square plus v2 t plus v3 of 0. Now all are in this form. Fine. So how you can think about that? Look at the last line. The last line is dy over d3 will be 0. So what does it mean? y3 will be my constant. You can see it is not a constant. Cancel out. Both are fine. Look at the second line. Second line means y2 over this is my y3. So y3 is my constant which is given as a 1. So what is my y2? If you integrate them, t plus constant, but it is not constant. Fine, it is here. From this case, dy over this will be my y2. y2 will be here. If you integrate them, it will be my this case. Fine. Now, check whether the last case will satisfied or not. What is that? Matrix A. What is the eigenvalues of this matrix? That means it is my nilpotent. It is my 3 cross 3. Fine. A cube will be my 0. So now e raised to power. So I can open that. T of A. T square over 2 factorial plus t cube. Q will be 0. So all the eigenvalues are 0 into y naught. Y naught is 1, 1, 1. Fine. Now I can write this matrix A with respect to the basis. What is my basis? I can return this is here. Then fine. 0, 0, 1 of 1, 1, 1. So what is that? This is what is this case? If you open that, first one is the y1. Second one is 1 plus t. Third one is my, so that is nothing but my y1. So that is also the correct option of this problem. Okay, now you can see this is my non-homogeneous differential equation. So how you can solve the non-homogeneous? Firstly, can you find the eigenvalues? Lambda square plus minus of 2 minus of 6. So the eigenvalues are minus 3 plus of 2. So my solution will be C1 V1 e raised to power minus plus C2 V2 e raised to power of this plus non-homogeneous part, since it is my linear equation. Fine. So it is a linear equation. The solution will also in the form of the linear AT plus B CT plus D. Fine. Now look at that. My target is to, if I divide it by t here and this, and then I can take the limit as t approaches infinity. It is my finite number. Fine, because d is my one of the finite. So clearly say when you take t as infinity, this number will be 0. So this part will be 0. This number will be, it must be finite, so that means C2 must be 0. Because when you take t as infinity, it becomes infinity. But we need a finite answer, so C2 must be 0. So this answer will be A and C. So that means your target is to find the value of A and C only. Fine. That is the only target you need to find. Now how you can find the value of the A and C? Again very simple. If you look about this equation, y dash minus ay is h. I can substitute this value. What is the y dash? If my solution is, let's assume that my solution is of this form. Fine. So what is the y dash? With respect to A, C, A into y, this is my A. I can multiply this into here. So it will be, this is the 1 and 1. Fine. 1 plus 1, that is a plus C plus B plus D. 4 A into T plus 4B minus 2CT minus 2D. It is equal to H. H is my 3T plus 1, 2T plus 5. That's over. Now I can clear this screen for you. Now you can equate the coefficients. So I can equate the constant coefficient firstly. Left hand side is my 1. From this is a minus B minus D. C 4B minus 2D. But because of this negative sign, this plus it should be 5. Second part is I can equate the coefficient of the T. Minus A minus C will be 3. Minus 4A minus minus plus 2C is equal to 2. I need a value of the A and C. Our target is to find the value of A and C. I can solve this. I can multiply by 2 and add them. Minus 6A, 6, 8. So A will be minus 4 over 3. So first number A minus 4 over 3 is a plus 4 over 3 minus 4 over 3. So the right answer is A is my right answer. Okay, look at this another one. X is the solution of this equation. Can you find the auxiliary equation? 7, 10, 10 minus 6. So equations are 1 and 6. So what is my solution? It's a X. So my solution will be C1 V1 e raised to power 1 into t plus C2 V2 e raised to power 6 into t. What is the C1 and C2? Initial condition is not given. Which of the following statement is true? X of t is my bounded. Is it a bounded? What is the meaning of the bounded? That means if I put t as infinity, this x will be my finite, but it will goes to the infinity. Fine. So first option is cancel out. Now what is the solution of e raised to power minus 6 into x? So it will be C1 V1 e raised to power minus 5 into t plus C2 into V2. Does it goes to the 0 as t tends to infinity? T tends to infinity, this part will goes to the 0. So this part will goes to the C2 V2. Does it always goes to the 0? No, because C2 is my undefined. So I can choose C2 is my 1 or C2 is my 4. Fine. Then clearly say this number will never be goes to the 0 always. So that option is also cancelled. When you multiply this number by e raised to power minus of t into x, it will be C1 V1 plus C2 V2 e raised to power minus 5 into t. So it goes to the infinity when t tends to it's a plus. Does it always? So it's a constant number. Fine. when t tends to infinity, this number will go to the infinity, fine, but provided C2 should be non-zero. But it is not given that C2 is always non-zero. So if I choose C2 initial condition such a way that C2 will be 0, then this component will be constant, but he said infinity. So this will be infinity only if C2 will be my non-zero, but that condition is not given. When you take e raised to power minus of 10, then C1 e raised to power minus 90 plus C2 V2 e raised to power minus 4 into t. Now clearly say this will goes to the 0 as and t approaches infinity, whatever the C1. This will also goes to the 0 whatever the C1. If both are my 0, then again goes to the 0. If one of them is goes to the 0, then again 0. In all the case, fourth is my right answer of the problem. Okay, look at this one. So x1, y2 and x2, these are my solution of this. If you remember that, this is nothing but just like say Wronskian. You can see I can return this number as here. What is that? If I consider x1, y2 minus y1, so that's a Wronskian. So what is the case? As I told you, trace of the matrix into W. So can you write the matrix A? Minus 1. What is the trace of this matrix? Minus of 2. W is the, because W written here as a 5, so minus of 2, W is the right answer. This is the first method. There is one more method. What is that method is? If you don't understand that whether it's a Wronskian or not, your target is to find the derivative. Can you find the derivative of this? So x1 prime y2 plus x1 y2 prime minus x2 prime y1 minus x2 y1 prime. So I can substitute the x1 prime from here because x and y are the solution of this. So it is minus x1 plus t times y1 of y2 plus y2 is the solution of this. So t times x2 minus y2. x2 prime is also the solution of this. x2 plus t times of y2, and x1 is y1 prime is also the solution of this second part, x1. Now if you open them, again you will get the same answer as here. Okay, look at this another one. The critical point of this. Very simple. How you can find the critical point, or how you can check whether this is stable or not? Consider the 2 points f and g. That means dx over dt I can consider as a f. This is the type 2. Fine. This is the type 2 of this. Fine. Always find the Jacobian. Always find the Jacobian. How you can find the Jacobian? That means del f upon del x, del f upon del y, del g upon del x, del g upon del y, and the critical point is given to you. Check, find the Jacobian at the point of the critical point. Then what is the nature? How you can identify that? So that means whether it's a stable, spiral, unstable, and so on. So find the eigenvalue always. Fine. Then whenever you will find the roots are my opposite sign, that means whenever the eigenvalues are opposite sign, that means if eigenvalue is my 1, that's a positive, other value is my negative, one is the positive, second is my negative, then always be the unstable, and the critical point is saddle point. Whenever you will find the roots are real, same sign, but they are not equal, that means when both are my positive or both are my negative, then always be the node. Fine. When they are the reals, when both are the reals and the same sign or the opposite sign, you get as a node. Whenever they are the opposite sign, saddle. Whenever you have the same sign or the real, that's a node. When you can say it's unstable, when the roots are negative, stable when the roots are positive. On the other hand, if my complex numbers, then is called as a spiral, and if it's a purely imaginary, then we call as the center. Now look at the same example. Can you find the Jacobian? What is the partial derivative of this with respect to x? 1 plus y square cos x. Partial derivative with respect to y plus 2y sin x. Partial derivative with respect to x. Partial derivative with respect to y. So it is a 3 cos y square, and cos will be the minus, sin y square will be 2y, is a 6y square. Fine. Now add the point of 0 comma 0. So this number will be cos 0 is 1, y 0 is 0 here, sin 0 is 0, this is 0, cos 0 is 1, it's a minus 5. So can you find the eigenvalues? Trace, determinant is minus 5 plus 4. Fine. So eigenvalues are my minus 4 plus minus 16 plus 4 divided by 2. So it's a minus 2 plus minus 20 means 2 root 5. That's a root 5. Fine. So eigenvalues are 2 plus root 5 and minus 2 minus root 5. Clear? Now clearly say this number is my less than 0. This number is my greater than 0. That means opposite sign. Whenever you have the opposite sign, you always call as the saddle point. So that means spiral only when you have the imaginary roots. Node only when you have the real roots. But that's a real, but they have the opposite sign. So the saddle point is the right answer. Okay, critical point is given. So firstly find the Jacobian. Partial derivative, I can open this bracket. It's a 3x minus 2x square minus 2xy. Find the first derivative with respect to x. 3 minus 4x minus 2y. With respect to y, here I can open this bracket, 2y minus 2xy square here. With respect to x, 2y. With respect to y, here. Fine. Critical point is 0 comma 2. So I can substitute here. X is my 0, x is my 0, x is my 0. So y is equal to 2. So it's a minus 1, minus 4, 0, 2, minus 4, minus 2. So what are the eigenvalues? It's upper triangular, minus 1, minus 2. That means same sign. Fine. They are the real. Clear? So once you will get the same sign and they are the reals. So you can see about that this concept. Real, unequal, same sign you will get as the node. Asymptotically stable only when you get the negative. Whenever positive, unstable. So now we will get as both are negative. So that means it's a asymptotically. Spiral is not possible because it's not a complex. Unstable, not possible. So that's the right answer is stable is the correct option of this problem. Okay, look at this another one. Again they are talking about the, firstly you can find the critical point is not given. So you can find the critical point. You can put this number as a 0, x minus 2y as a 0. You can solve them. You will get 0 comma 0 is the critical point. Write the matrix J, derivative, derivative. This minus 4. Fine. Now find the eigenvalues. Lambda square is a 6. Determinant will be 8 plus 9. So eigenvalues are minus 3, minus 3. So they are the reals. They are the equal, but they are the real, equal and the negative sign. So spiral is not possible because they are not complex numbers. Spiral is not possible. Now whether stable or unstable, because they are my negative, so negative is always be asymptotically stable. Whenever they have the positive values, then it's unstable. So stable is the right answer of the problem. Okay, again the critical point is given. Can you find the Jacobian matrix? First derivative x with respect to y, x with respect to y. So can you find the eigenvalues? Plus is a minus 16 plus 21, that is a 5. So eigenvalues are minus 1, minus 5. Again real, unequal and negative. So spiral is cancelled because they are the not complex number. Fine. Both are the negatives, so it means it is asymptotically stable or called as the stable. So unstable is not possible. So this is the right answer. Fine. Remember always the two cases, whether it's a spiral or node. Node when the roots are my real, spiral when the roots are my complex. And it is a unstable when roots are my positive and stable when the roots are negative. Critical point is already given. So find the j firstly, partial derivative with respect to x, partial with respect to y, partial with respect to x, partial with respect to y. At the point 0, 0, minus 2, 0, minus 1, 3. Eigenvalues are, is a upper triangular matrix, minus 2, 3. Fine. They are the real but opposite sign. Fine. So once they are the opposite sign, it means they are my saddle point. So they are the saddle. Spiral again when the complex number. Okay, consider the system of the equations when closed path or not. Again, if I consider this is my f, this is my g, when it will have the closed path. If you consider first one, partial derivative with respect to x, second one with respect to y. Fine. If it is greater than 0 for all those elements in the domain, fine, then it implies they have no closed path. Fine. Now you can check about that. Partial derivative of f with respect to x, 12x square y square, 5x4 y4, plus g with respect to y, 5x4 y4, plus 6x square y square. This will be cancelled out. It's a 18x square y square. Now it's a less than of this. Whenever you consider this number, first of all, this number is always greater than 0. Fine. Provided x and y for all x and y, and it's a 0 whenever x and y are 0. So that means this number is no closed path. But he said closed path in this domain. That's not possible. Whenever you consider this is the outer circle. So whenever you consider this circle, it will be greater than 0. So that means closed path not exist. In this case again, you will get as greater than 0. In this case also you can get as a greater than 0. So your right answer is D is my right answer. Okay, system of the equation is given. Your target is find the x square and here. Okay. So if you look about the option, your target is to be here. So how you can make them from here? Can you write x squared in terms of the dx dt? I can differentiate them. Fine. This is your purpose. I can divide them. Fine. So what is the division of this? Dx over dy will be minus y over x. So that means x dx plus y dy is equal to 0. Integrating them, x square over 2, y square over 2 is constant over 2. Fine. Now x naught and y naught is there, so c will be a square plus b square. So my solution is x square plus y square is a square plus b square for all the pairs of x comma y. He said only for any pair. X square plus y square is equal to this. It goes to the infinity as t approaches infinity. If I choose a is my 1, b is greater than again 1, then this number will go to the 2, which is not infinity. So this option is cancelled out. B and C are the right answer of this problem. Okay, look at this another one. Again, your target is to be x square and y square. The first number will be my dx over dt. I can write here. Dx over dt will be y plus x, 1 minus x square minus y square. Second number will be minus x plus y times of this. Fine. Your target is to make them as a x square and y square. If you divide them, it will not be cancelled out. Fine. So what I can do is, I can multiply this by x, this by y and add them. So the first term will be x, this, plus y, dy over dt, xy, xy, this will be cancelled out, x square, y square. So x square plus y square, this is common and this is my here. Fine. Now that's over. I can write this equation as x dx plus y dy over, fine, dt I can written here. I can multiply 2, 2 and 2. So what is that? X square plus y square. I can choose it as some number, say r. Fine. So this numerator will be my dr. This is r. 1 minus r is twice of dt. Now you can integrate them. How you can integrate them? I can use the partial fraction. Fine. So you can integrate them. So for the integration, I can use the partial fraction, 1 minus r. So when r is equal to 0, it is 1, it will be my minus 1. Sorry, it's a plus 1 again. When it is r is equal to 0, it is my 1. When r is equal to 1, it will be 1 minus r. So it is my 2 times dt. So what is that? It's a log of r. It is my 1 minus r. So it's a plus log of 1 minus r divided by its derivative. 2 times t plus constant. So I can say r over 1 minus r is log, I can written as here. Fine. Now look at the option. X square plus y square, that means r. R goes to the infinity as t approaches infinity. When t approaches infinity, this part will goes to the infinity, because c is my finite number. I can see about here. Fine. So this number will be infinity only when r will goes to the 1. So r will goes to the 1 as t approaches infinity. So this first option cancel. T approaches infinity, this option is cancelled. X square plus y square remain bounded. So clearly say r approaches toward the 1 as t approaches, and this is a constant. So clearly say this approaches 1, which is less than of some finite number. So the C and D are my right answers. Okay, look at this another one. F is a locally Lipschitz function. System of the equation dx, it will be sine of x2, and this will be any of the function which satisfies this condition. Which of the following is my true? Okay, there always exists a global solution. Wrong option, because this system is my locally, not globally Lipschitz condition. So there it means global solution may exist or may not, but he said always. That's why this option is cancelled. There might not be any solution. You can see one solution is already given that, but he said no solution. That option is also cancelled. What is the meaning of the locally Lipschitz condition? That means if you take the partial derivative of this f with respect to x2, it should be finite. What does it mean? Whenever it will satisfy the Lipschitz condition, that means you will get a one solution. Fine. So that means at most one solution will be here. One solution will be here. at least one solution will be here. So that means because this condition also satisfied one solution, this condition also satisfied. Unique solution only satisfied when it will satisfied as a global Lipschitz condition, but it's a locally, so it means it's at least or at most one solution will be there. Okay, look at this another one. X and y are the continuously differentiable functions satisfied this. Define capital Z to be here. Okay, y minus z. If I subtract them, you will get this equation. This is a constant. Oh, sorry, this is a common term. I can written as here. So this will be my z, and this will be my t minus log of 1 plus t. Fine. And what is the z of 0 will be? Z of 0, y0 minus x0, that is my 1. Now how you can find the solution? Can you find the integrating factor? E raised to power sine of t minus 1. So e raised to power minus cos t minus t. So solution will be z into integrating factor. Fine. This is integration of t minus log of 1 plus of c, because the initial condition is given to you, so I can take it as 0 to t. Then the value of, now how you can find the c, because z0 is my 1, so what is the value of the 0? This limit will be 0 from the 0 to 0. Cos of 0 is 1, this is 0, this is my 1, e raised to power minus 1, 0 plus c, so c will be my 1 over e. Fine. Now look at the option. Now I can check about the point at 1. So what is the answer of this? Z of 1, it will be e raised to power minus cos 1 minus 1. It is 1 to 0, t minus of 1 plus t plus 1 over e. So I can write this. What is the log of 1 plus t? It is x minus x square over 2 plus x cube over 3 minus x4 over 4 plus and so on. So if you open them, it will be my t square over 2 minus t cube over 3 and so on. So z of 1, it will be e raised to power 1 plus cos of t, 0 to t, it will be t square over 2, t cube over 3 and so on, plus 1 over e of 1 plus cos of t. Fine. Now I can take this component as, this number is nothing but e raised to power cos of t. Now clearly say e raised to power cos of t. Now this number is my positive. Fine. This number is my positive, because you can see that if you integrate them, it will be my t cube by 3, that's 1 over 6, 1 over 9, and it's a positive number. Fine. So this is positive, and t of 1, so it is my 1. So cos of 1, e raised to power something is always be greater than 1. This number is my greater than 1. 1 plus positive number is greater than 1. Fine. First and the third option is, first option is cancel out. Now look at these other solutions. Now your target is to find the Z2, whether the Z2 is greater than Z1 or not. Now I can written as a Z2. It will be e raised to power 2 plus cos of 2 from 0 to 2, t minus log of 1 plus t plus 1 over e of this value. So that means e of 1 plus cos of 2. Now whether it's a greater than Z1 or less than Z1. So you can see I can written this component as cos of 1 into cos of 1 plus 1. Fine. This number also I can written as e of 1 plus cos of 2. Fine. Of this number. Now, what is the z1? This number is my, clearly say, this number is greater than of this number. Fine. This number is greater than of this number, definitely, because its limit is my 0 to 1. This is my 0 to 2. Fine. So this number will definitely be greater than of z of 1, because each number has greater than of this. So z2 must be greater than of z1. So this number is also cancelled. So the right answers are C, B and C are the right answer of this problem. You can join with me through my WhatsApp group. You can scan and join my WhatsApp group as here. I hope you can like, share and comment on my video as well. We will see the next lecture, more lectures on this. Till then, you can simply like, share and comment on video. Best of luck, students. Happy learning.